Okay, so good morning students. Welcome to the real analysis live lectures. In a previous lecture we have seen lim sup and limin. In today's section we are going to see what is countability. Means in that countable set, uncountable set, finite, infinite, equivalent sets and all that. Okay, so next section is countability. Let me erase this one. Countability. Section 4. This is this 12th lecture, right?
Yes.
Okay. So before going to countability, first we will define equivalent sets. Equivalent sets. So two sets A and B are said to be equivalent. Are said to be equivalent if there exists a bijective map between them. What is meant by a bijective map? Can you hear me?
1 and on 2.
Yes.
1 and on 2.
1 and on 2. So if there exists a bijective map between A and B, then we say that two sets are equivalent to each other. So if A is equivalent to B means B is also equivalent to A.
Yes.
Because
Yes, ma'am.
since it is bijective map. Okay. So this is yes. So clearly, or we can say note. We denote A and equivalent to B by we denote A equivalent to B by notation tilde. This A equivalent to B. Okay, this is the notation. Note, we can say, or we can easily show that this tilde is a equivalence relation. Clearly, this tilde is an equivalence relation. Can you show this? Tilde is an equivalence relation. Whether it is reflexive relation, A is always equivalent to A itself.
Yes, ma'am.
Yeah, and if A is equivalent to B, B is also equivalent to A.
Yes.
And A is equivalent to B, B is equivalent to C, then A is equivalent to C, we can show. So that tilde relation is transitive also. Therefore,
Yes,
clearly we can say that this equivalent sets relation is an equivalence relation. Okay, you can prove this. Okay, next definition. finite set. A set is said to be finite. A set is said to be if it is either empty or equivalent to the set 1, 2, 3 up to n for some natural number n. Natural number n. Okay. So what is a finite? Can you give example of a finite set? Either it is empty or it is equivalent to some set 1 to n where n is a natural number. Can you give me an example? Any finite set?
Set of positive integers.
Set of
Positive integer.
positive integer. Whether it is a finite set?
No, ma'am.
Can you give me a natural number for which there is that is equivalent to 1 to up to n? It is not finite set, no? Integers infinite set. Okay, let me define infinite set. Finite means everybody know bijective relation, bijective map, 1 1 and on 2. Okay. Anyhow, we have to prove in next in examples. So at that time you will come to know. For example, I will write here. A is equal to 1, 2, 3, or A is equal to say A, E, I, O, U. This is a finite set, right?
Yes, ma'am.
What is the equivalence? What is the natural number for which it is equivalent?
5.
5. For this it is 3, like that. Or set is equal to say AB, CD, whatever you can take. So order pairs, I have taken 2 order pairs. 2 elements it consists of. Okay. Or set of all elements which are divisible by or divisors of 6. Set of divisors of 6. So how many divisors are there for 6?
4. 2, 3. 6. 4.
1, 2,
1, 2, 3.
3 and 6. So this is equivalent to 1, 2, 3, 4, right? So this is a finite set. Is that okay?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes. So we'll go to the now in if it is not finite, then it's said to be infinite. So next definition. You can write infinite set. So when I can say a set is infinite now, if it is not finite, right?
Yes, ma'am.
A set
Yes.
X is said to be infinite if it is not finite, means there does not exist a natural number. There does not exist a natural number n belongs to n such that x is equivalent to 1 to up to n, right?
Yes, ma'am.
For example, now you can give, can you tell me any infinite set?
Set of natural numbers.
Set of natural numbers is also infinite, right?
Positive integer.
Set of positive integers, or r plus z plus I can write. Z also
Yes, ma'am.
integers. What about q? Rationals.
Yes.
It is infinite,
Yes. Yes.
etc. Okay. So now, what is countable set? Countable set. When we say that a set is countable,
When we can assign a number with each element.
if it is finite, or a set X is said to be countable if it is finite, or if either it is finite or equivalent to which set? Set of natural numbers. Equivalent to set of natural numbers. Okay. For example, one, two, three, all finite sets. Set of natural numbers is a countable set. Again, Q, set of rational numbers, is a countable set. We have to prove it, okay? Anyhow, in next theorem, we have to prove set of rational numbers is countable. We are going to prove it. Whereas R is not countable. Okay. Here, otherwise it's said to be uncountable. Otherwise, said to be uncountable. Uncountable. Is that okay?
Yes, ma'am.
Yes.
So these are countable sets. Which are not countable? These are countable. Examples of countable sets. Now can you give me an uncountable set? Example of an uncountable set. What about R? Set of all real numbers, whether it is countable. Are you there, students? Set of real numbers, whether it is countable.
No, ma'am.
Yes. Then any another example?
Complex numbers.
Set of whole
Complex numbers. Yes.
Irrational.
Irrational. Irrational, whether it is countable or uncountable. Q complement.
Uncountable.
Countable or uncountable? Uncountable. Okay. Because R is nothing but Q union Q complement. If Q and Q complement both are countable, then union of countable set is also countable. So R must be countable, but we know R is not countable. Okay. We will prove one by one these things. Is that okay? These definitions are clear. Finite set, infinite set, countable set and uncountable set. Is that okay?
Yes, ma'am.
Okay. Now prove that, we can take example. Prove that Z is countable. So how we can prove this? Z is countable set of integers. We can add over here. Obviously 1 2 3 this is a finite for this 1 2 3 this is finite set, so this is countable. What about n? How can I say n is countable? Because n is equivalent to itself, set of natural numbers. Therefore n is countable. What about z? Now for to show z is countable, we want to give a what? We want to show z is equivalent to n, set of natural numbers. So we want to give a bijective relation between z and n. Then we can say that z is countable set. How can I say?
फंक्शन घ्यावं लागते ना मॅडम.
Yes.
n प्लस इकडून एक फंक्शन डिफाइन करावं लागेल n plus 1
We
divided
have
by
to
2.
define a function from n to z or z to n, whatever. And we have to show it is a 1 1 and onto. If it is 1 1 and onto, then that map will be bijective, so we can say that z is countable.
Natural numbers to integers as a function define करावं.
To show this, we define a map f from n to z. Shall I define? By which
Yes,
one?
madam.
F of n is equal to say n by 2. If n is
Madam, odd set and even.
even, yes. And what can I take here? We want integers, no? 1 minus n by 2. If I take, if n is odd, check whether this will serve our purpose.
1 minus or n minus.
n minus 1 or 1 minus n. मी जर 3 घेतलं तर 1 minus 3. So minus I will get, right?
Yes, ma'am.
If we take odd natural numbers, then we get negative integers, right?
Yeah.
And if I take even natural numbers, then I will get all positive integers.
What?
Is that right?
Yes, ma'am.
Yeah. 1 minus, for n is equal to 1, what will be f of n?
0.
0. For, I can write here. Which pen? Okay. For n is equal to 1, what is f of n? It is 0. For n is equal to 2, what is f of n? 1, right? For
One.
n is equal to 3, f of n 1 minus 3 by 2. What will be this? Minus 1, right? N is equal to 4. F of n will be 2. For n is equal to 5, f of n will be minus 2
Minus 2.
Minus 2.
and so on. Is that okay?
Yes, ma'am.
Okay.
3 and so on. So we can have all integers, right? With the help of natural numbers, we can find all integers here. So now we want to prove this map is bijective. If we show this map is bijective, then we can say that this z is equivalent to n or n is equivalent to z. So how can I show this map? We have defined a map. Now to show this f is, claim f is bijective. Claim f is 1 1 and onto by that is 1 1
1 correspondence.
and onto. How can I show this f is 1 1? So consider, to show 1 1, what we consider? F of n1 is equal to f of n2, and show n1 is equal to n2, right?
Yes, ma'am.
So consider f of n1 is equal to f of n2, or let n1 n2 belongs to n and then right. Okay. Let n1 comma n2 belongs to set of natural numbers. Now consider their images is same. n1 is equal to f of n2. That is what this implies.
N1 equals to N2.
n1 n1 is equal to n2
Yes, ma'am.
if n is either n1 is even or it will be odd, right? If both are even, both are odd, you can do like that, or we can prove like this also. Or better to choose, okay. How can I show? n1 by 2 is equal to n2 by 2. How can I say? Which will be the cases?
N1 by 2 and N2 by 2 will be equal.
Suppose
and
n1 and
also
n2
for
both are
given function.
even.
Hmm.
Both are even. So there will be different cases. n1 and n2 both are odd, both are even, or one is even and one is odd. Right? So these three cases we have to prove.
Yeah.
Like this. Okay, let me erase this. if case 1, if n1 and n2 both are even, then
N1 by 2 equals
f of n1 is equal to f of n2 implies n1 by 2 is equal to n2 by 2, and this implies n1 is equal to n2. What is case 2? If n1 comma n2 both are odd. If both are odd, then f of n1 is equal to f of n2 implies what? 1 minus
1 minus
n1 by 2 is equal to 1 minus n2 by 2, and this clearly gives me n1 is equal to n2, right?
Yes, ma'am.
Yes. And what is case 3? Suppose one is even and another one is odd. Suppose n1 is even and n2 is odd, then whether it will give
N1 by 2.
what this implies, n1 by 2 is equal to 1 minus n2 by
N2 by 2.
2. It won't give, no?
Yes, ma'am.
Yeah, odd means we have to write in 2 times something. One is even, one is odd. Images can't be same, na? Even and odd. So this case 3 is not valid actually, because f of n1 can't be equal to f of n2, right? So only 2 cases will be there. Is that okay?
Yes, ma'am.
So this implies therefore f is 1 1. This implies f is 1 1. Now to show f is onto. How can I show f is onto?
Then exist.
What is my f? F is from n to z, no?
Yes.
Actually, we might have started with z to n, no? That will be easy. Okay, no problem. Anyhow. F from n to z. What is mean by onto? For every element in codomain, we should have a pre-image, right?
Yes.
So what can I say now? So let z belongs to z. Again, it will be either positive or negative, right? Positive integer or negative integer. If z is positive, we can suppose z is 3. What natural number we will have?
4.
2.
No, 6, no? 6 by 2 I will get now. Just now we have written here.
Yes, ma'am.
For 3. For 3 I will have preimage 6. For 0 n is equal to 1 will serve. For 1 there exists a natural number 2, like that. So if from this we can easily have, but we have to write it in. How can we define now? How can we show it is onto?
For every z belongs to z, there exists n belongs to natural numbers like that, z equal to 2n.
Yeah, but
2n.
2n il आणि
But for even it will be 2n.
2z नॅचरल
No.
2 केसेस मध्ये यायला पाहिजे ना आपल्याला. याच्यापेक्षा ते पहिले we might have taken that might have easy z to n. इझी म्हणण्यापेक्षा यालाही करू शकतो, बट इट इज हाऊ टू टेक. इफ झेड पॉझिटिव्ह पाहिजे तर आपल्याला इवन नंबर घ्यावा लागेल. 2 times z will serve. Z is positive, then 2 times z will be that natural number. Okay. Two times z will belongs to natural number, and if z is negative, then what I have to take? Z negative असेल तर टू टाइम्स z 1 minus 2 times z, right? 1 minus 2 times z. One minus 2 times z. 2 times z. That will also belongs to a natural number. Are you getting this? Z म्हणजे हा ना small z. It is just a element. For m we will take m. Are you getting this?
Yes, ma'am.
m जर निगेटिव्ह म्हणजे -1 आहे समजा. -1 साठी which natural number we will get? 3. मग इथे घेतलेलं आहे ना. Is that right? If -2, then yes, it will serve purpose. Is that okay? So for every M, for every integer Z, we will have a pre-image that will belongs to natural numbers. Is that okay?
Yes, ma'am.
Yes, ma'am.
Therefore, M is on to. Therefore, F is on to. Or otherwise, you better define. You can define a map F from Z to N. Okay, N to Z च्या ऐवजी Z to N करा. How can I define a map? By F of N is equal to, what can I take now? 2n and 1 minus 2n will serve the purpose.
Yes, ma'am.
And minus 2n. So what I have to take here? N
For any
is
given.
greater equal to 1 positive, and if n is
No.
positive असेल तर 2 times n ना,
Yes, ma'am.
positive, and if it is negative less than 1. Is that okay?
Yes, ma'am.
Then it will serve my purpose. And that will be easy to check 1 1 and on to. Okay. Now you take how I will show this is bijective. Now let n1 comma n2 belongs to Z, and consider f of n1 is equal to f of n2. Again there will be two cases, whatever we have shown. The same thing will happen. Okay, no problem. Is that okay? असे घेतलं तर तेच येते, तसे घेतलं तर केसेस मध्येच येईल ते. तिथे इवन ऑड घेतला होता, इथे आपल्याला पॉझिटिव्ह निगेटिव्ह घ्यावं लागेल. Is that okay?
Yes, ma'am.
Yes, ma'am.
Okay, so next example, n cross n. Show that n cross n is countable. Show that n cross n is countable. So how can I show this is countable now? I have to define a map. I have to define a map f from n to n cross n, right? Which is bijective. Can you, okay, for this I will require fundamental theorem of arithmetic. What is fundamental theorem of arithmetic? Can anybody tell me? Recall? Are you there, students? Fundamental theorem of arithmetic says that each positive integer k belongs to n can be uniquely expressed as k is equal to 2 raised to m minus 1 into 2n minus 1 for some m comma n belongs to again natural number. So you take for example, if I take k is equal to 5 or 3, you get 5, k is equal to 3. Can you give me m and n which will serve the purpose?
M will be 0 and N will be 2.
N will be 2, m will be,
0 and 2.
m is 0.
N is 2.
0 कसं येईल?
2 to the power 0. 1.
1. 1. M is equal to 1 na?
1.
M is equal to 1 if I take, right? M is equal to 1 ला हे 1 होईल आणि 2n minus 1, 2 times 2, 4 minus 1 will be 2. Is that okay? This m is equal to 1, n is equal to 2. If k is equal to 1 पाहिजे असेल तर what is m and n? K is equal to 2. What is m?
N is 1 and
If
M1 and 1.
m is
M1 and 1.
m1 and 1, right? Now for k is equal to 2, 2 raised to 1 पाहिजे मला for m1 and 2 यायला पाहिजे ना. So even I want 2 raised to 1 पाहिजे मला, तर m is equal to 2 and n is equal to 1, right?
Yes, sir.
Yes. Now k is equal to 4 असेल तर what should be m and n? 4 म्हणजे 2 square पाहिजे ना. So m should be 3, n will be 1. Is that right? Yeah, like that. We will have unique representation for every k. There will be unique representation where 2 raised to m minus 1, 2n minus 1, like that, where m and n are these values. So this theorem is known as fundamental theorem of arithmetic. For each positive integer k can be uniquely expressed as k is equal to 2 raised to m minus 1, 2n minus 1 for some m n belongs to n. Okay, now I want to, why I am using this, because I want to define a bijective map from set of natural numbers to cross product of natural numbers. Okay, so now we can define a map f from n to n cross n by f of k is equal to m comma n, where k is nothing but 2 raised to m minus 1 to n minus 1. Is that okay? Now I can define, this is a well defined map.
Yes, ma'am.
Yeah, so now I want to show this is a bijective map. So to show 1 let f of k1 is equal to f of k2. So what this implies, k1 will be uniquely expressed as 2 raised to m1 minus 1 to n1 minus 1 and 2 raised to m2 minus 1 or we can write where k1 is equal to 2 raised to m1 minus 1 2n1 minus 1 and k2 say uniquely expressed as 2 raised to m2 minus 1 2 times n2 minus 1. Okay, so 2 times n2 minus 1. So what this implies? When this will be same, when this will be equal, if and only m1 is equal to m2 and n1 is equal to n2, right?
Yes, ma'am.
So this implies f is 1 1. Now to show it is onto, how can I say it is onto? Let mn belongs to n cross n from codomain. Then take k is equal to 2 raised to m minus 1 to n minus 1. That will belongs to, right? Is that okay?
Yes, ma'am.
What will be my f of k then? It will be just m order pair mn. Then this implies f is onto. Therefore, f is a bijective map. And hence, n cross n is counted. Is that okay?
Ma'am, yes, ma'am. Please explain to show F is onto again.
काय?
F is onto.
Onto actually याच्यावरूनच येतं. Onto means what? For every element in codomain, we should have a pre-image, right?
Yes.
So if you take m and n, then you take that you will get a natural number 2 raised to m minus 1 to n minus 1, whatever you will take, that will be your natural number. The same thing I have written here. Start with any arbitrary element from n cross n codomain, okay? And then you will have a k which belongs to n. So it will be onto. Can I लिहिलं तरी चालेल? Okay, it will give you. Is that okay?
Yes, ma'am.
कोणतं element तुम्ही घ्या n cross n मधलं. Suppose you take 2 3 belongs to n cross n. So which natural number you can give? So k will be my 2 raised to 2 minus 1 and 2 into 3 minus 1. So what is this? 2 times 6 minus 1.
5.
5. So that will be 10. Right? So that belongs to natural number. So whatever element you take from n cross n, you will get a natural number. Is that okay?
Yes, ma'am.
Are you getting this? Onto means what? For every codomain, you should have a pre-image. That much only. for every element in codomain, you should have a pre-image in domain. Domain is set of natural numbers. Codomain is set of n cross n. N cross means just order pair of mn. Are you getting this? Is that okay?
Yes, ma'am.
Yes, ma'am.
Actually, these are trivial, but we will require these things to prove next theorem. So I am taking this. Actually, if n is countable, then n cross n is always countable. But now from using this, we have to prove now a cross, if a and b are countable, a cross b is countable. Okay, so now we will take a theorem. If a and b are countable, then a cross b is also countable. So how can I prove this now? A and b are countable given, and I want to prove a cross b is countable. Prove. Since since a and b are countable, a is countable means there exists a bijective map.
Yes, ma'am.
There exist bijective maps. Two bijective maps we will have. Maps f from a to n and say g from b to n, right? So there, since a is countable, there exists a bijective map from a to n, say it is f, and there exists bijective map from b to n also, say it is g. Is that right? Now using these two maps, we have to define a new map which is bijective. Okay. Now define a map H from A cross B to N cross N. N cross N by H of AB is equal to F of A comma G of B. If I define this map, can I define this map? Let A from A, B from B, small b from capital B, and I am defining a map F of A comma G of B, and I will show this is a bijective map. Then A cross B is equivalent to N cross N, and since it is a transitive, N is already equivalent to N cross N, therefore A cross B is also equivalent to N. Therefore, A cross B will be countable. So for that we have to show H is bijective now. How can I show H is bijective now? H is well defined. H is well defined map. Now I want to show it is a let H of A1 B1 is equal to again order pair all, because this will be order pairs. A cross B. Is that okay? This will be order pair. H of A2 comma B2, or we let A1 B1 comma A2 B2 belongs to A cross B. Consider this. So H of A1 B1 is equal to H of A2 B2 means what? F of A1 comma G of B1 is same as F of A2 comma G of B2. Is that right? By definition of H. But two order pairs are same if and only if they are coordinate wise same. G of B1 is equal to G of B2, and this implies A1 is equal to A2 and B1 is equal to B2. Why? What is the reason? Because F is 1 1 and G is also 1 1. F comma G are 1 1, right? Since they are 1 1, F of A1 is equal to F of A2 implies A1 is equal to A2. G of B1 is equal to G of B2 implies B1 is equal to B2, and this implies A1 B1 is equal to A2 B2. Is that okay? Is this okay? Therefore, H is 1 1. Now I want to show it is onto. Now to show H is onto. So to show H is onto, what I have to do? Let M comma N belongs to N cross N. So since F and G are onto, what there exists? A belongs to A and B belongs to B, such that what? F of A is equal to M and G of B is equal to N. Is that right?
Yes, ma'am.
So H of AB is nothing but F of A comma F of B, and that I can write as M comma. Therefore H is onto. And hence H is a bijective map. Now H is a bijective map from where to where?
A cross B to N cross N.
Yeah, A cross B to N cross N. So what this implies? A cross B is equivalent to N cross N. That is, A cross B is equivalent to N cross N. But N cross N is equivalent to N.
Yes.
is equivalent to n also. So this implies A cross B is equivalent to n. Therefore, A cross B is countable set. Is that okay? By transitivity.
Yes.
Is that okay?
Yes, ma'am.
Yes, ma'am.